Hello everyone and welcome to another problem solving session, Special Maths Academy. And today's video we are going to be covering a problem from the Senior First Round Mathematics Olympiad 2020. That is problem 19, so let's go to the question now. How many ways can 2 red, 2 blue and 2 green identical balls be placed into 2 red, 2 blue and 2 green distinct boxes in such a way that each box contains exactly one ball of a different color? These are the options. So first of all, we have to take note of some important details given here. We are given the question that the balls of the same color are identical, so you can't differentiate them. And also we are given that the boxes of the same color are distinct, so you can differentiate the boxes, like the two boxes of maybe, for example, the green color. You can be able to differentiate them. So that it will influence the way we count some things, as we see later on. So now to the solution. This question, we are just going to try and break out the question to all the possible cases. The numbers we have in the question are relatively small, so we can split it into multiple cases and we'll be able to cover out everything. So that's how we go about it. So let me just draw the bins first of all. So this is the first red bin, second red bin, first blue bin, second blue bin, first green bin, second green bin. Okay, so what we're going to do now is, as I say, we split the question down to multiple cases. Remember, the condition for this question is that each box contains exactly one ball of a different color. So for example, now in these 2 red bins, we're not expecting any red to be inside here. And in these 2 blue bins, similarly in these 2 blue, we're not expecting any blue. These 2 green bins, we're expecting only red and blue to be inside here. Either red or blue to be inside here. So how I did this question, first of all, I first of all started with the way I drew the diagram here, the first 2 boxes are the red ones. So I did a case 1 when both balls in the red ball, when both balls in the 2 red boxes are of the same color, And the other case is when they are of different colors. As I said, the numbers here are relatively small, so we just count 2 of them individually and get the answer. So now when both balls in the 2 red boxes are of the same color, what color can that be? Definitely it cannot be red. So it's either blue or green. So we now start doing our cases. So it means it's either green. Let G stand for green ball. And wherever I'm writing thunder, just imagine you're placing the letters inside the boxes. So it's either green. Then okay, so now if the 2 boxes in the green, if the 2 boxes in the red, if the 2 balls in the red boxes are both green, so we'll be left with what? We'll be left with 4 balls. And out of those 4 balls, 2 will be red and 2 will be blue. So now for these blue boxes now, remember we should not put any blue ball inside these 2 blue boxes. And we have only 4 more left. Let me draw some lines now. We have 1, 2, 3, 4. We have 4 more left. We have two blues, and we should not put it into any of these 2. So definitely we should put the 2 blue balls into the green ones. This is the only possible way. And the 2 reds should be here. So this is the first case when the 2 balls, both balls in the red box are the same color. So the second case is when we start with blue, when both balls in the red boxes are blue and blue. So 3, 4, 5, 6. Then using similar arguments, we will be able to get that in the green boxes we have to have 2 red, because these blues cannot because these greens, in this second case we have 2 greens and 2 blues left. The greens cannot be under this place, so they have to be here. So these are all the possible configurations. And red definitely is not allowed because of this last condition here. Each box should contain exactly 1, so it's contradicting that they are the same color, so it's definitely not allowed. So these are the only 2 possible configurations when both balls in the two red boxes are of the same color. So now, for each of this configuration, we're going to like find number of ways such a configuration can occur. So what do I mean? Like, how many times can this occur? Remember, we have two green balls, but okay, this is meant to be red, sorry, not green. Let's be red. Yeah. Sorry about that. So now, in this case, now we have how many arrangements, how many ways can we like make two green balls to be inside this red, two red to be inside these two blue boxes, and two blues to be inside these two green boxes? There's only one way we can do this. But why am I saying there's only one way? For example, now if you swap this green ball, this second green ball, and put it in the first box, and this first one is second box, like they say the two balls, all the balls of the same color, they are identical, they can't be differentiated. That's why earlier on in the question, I say like these two facts are identical and distinct to help us to be able to count out some things. So because the balls of the same colors cannot be differentiated, there's only one way we can do this. So there's only one way. Similarly, there's only one way here. The balls cannot be differentiated. Even though the boxes can be differentiated, like imagine like you have two similar balls and put them into like two different boxes. If you like swap those two balls, you can't be able to differentiate it. So regardless of the fact that the boxes can be distinct, because of the fact that the two balls are identical, you cannot be able to like differentiate the counting. So we don't count more than one. So that's why there's only one way we can do this first arrangement, and only one way for us doing the second arrangement. So in this case, the total number of ways is 2 ways. There are only 2 ways it can happen. Now the second case, case 2. So remember the first case when both balls in the two red boxes are of the same color. This one is now, this second case 2 now, this case 2 is going to be what? When the balls in the two red boxes are of different colors. Okay. So let me draw the lines again. That's 1, 2, 3, 4, 5, 6. So for these two red, for the two balls to be different and them being able to be placed in the red boxes, remember, I'll see how this last condition. Definitely, the one ball has to be blue and one other ball has to be green, because no red ball can enter either of this or this. So one would be blue, one would be green. And now, after we have this, we are now left with two red balls, one blue and one green. So the one blue ball we have can enter, it cannot enter under here or here, because we can't place a blue ball inside the blue boxes. So we have to place the blue ball inside the green one. So we can write blue here. Then similarly, one green should enter here. Then we now have two spaces. So definitely red should be here and a red should be here. So in the configuration, when the two red boxes are of different colors, this is like the only possible configuration. But in this case now, like this configuration it doesn't occur only once. Because for example, now if let's say we did this now, this is going to be counted as a different thing. In this case, we just like swapped all the balls in the we just like this in the first case, the blue ball was in the first box, in the first red box, the green ball was in the second red box. Here I'll put the green ball in the first red box and the blue ball in the second red box. We swapped it. So this is like definitely a different arrangement from this. The reason why like everything was the same here was because like the two colors were the same. So these two arrangements are actually different. Why? Because they say the boxes are distinct. They are different boxes. If the boxes were the same, like if they're also like identical, then we could have had only one possible way here. But they say they are different boxes. They are distinct. Two distinct boxes. Two red, two blue, and two green distinct boxes. All of them are distinct. So this configuration is different from this first one. So it's not so difficult to like see that for each of these pairs here now, like you can put it either like this or like this. So and all these pairs are kind of like independent. They are independent. Like they don't really matter on each other. So by the multiplication principle, like total number of ways here will be like 2 That's like when you put the blue either in the first or the second one. This one also like have two possible ways. Also like have two possible ways. So because they are all independent, there's no intersection. The total number of arrangements help 2 times 2 times 2. So that's 8 ways. It means that in this case we have what? 8 ways. And now, if you notice, we have covered all the cases. Because like the first case was when both balls, the two balls in the red boxes will have the same color, and the second case when like they are not of the same color. So like those two sets, they don't intersect and they cover everything. So we are done with all our cases. So it means that the answer to this question is what? 2 plus 8. So that is 10. So there are 10 possible ways that we can arrive at what the question is asking us. So there are 10 possible configurations. 10 possible. And the answer to the question is the third option. Yeah. C equals option C. That is 10. So as I said, we are just a bit lucky that the numbers were small. The method is not really efficient per se, but numbers are not big, so that's why we're able to like handle all the cases. And yeah, the way I broke down these cases, I tried to make sure they don't intersect and I don't miss out any of the sets. So as you can see, we covered everything out. That's how I was able to do it. So this is all we have for today, and I'll see you some other time. Thanks for watching.